Hi and Assalamualaikum. My name is Nurhas Mishamin Muhammad Azmi. So today I want to present for the Signet Level assignment. This is our group members Muhammad Farhan bin Marzuki, EC21091, Muhammad Syafiq Johari bin Muhammad Safawi, EC21092, Nur Hasni Shah binti Muhammad Azmi, EC21098, and the last is Nur Hashmi Shah binti Rahimi Hazlim, EC21099. This is table of content for our assignment. The first is methodology, and the next is design calculation. This is for the manual calculation and discussion, and the last is conclusion. Okay, since we are group F, the amplitude that we get is 3.0 and the period T is 4. Okay, this is for our figure to find the exponential Fourier series for the first question. Okay, for the methodology, first is define predict function and calculate exponential Fourier series. Basically, this is for the focus on for question 1. We have to define the predict function using amplitude and period given and determine the expression for W node, C node, Cn, and N. Okay, next is implement Fourier series in MATLAB. This is for the starting this methodology. This is for the question 2. Write MATLAB code to calculate and plot Fourier series coefficient, amplitude and phase of harmonic. And the next is plot amplitude and phase harmonic to generate plot for the amplitude and phase harmonic. Next is reconstruct signal and analyze effect. This is we write code to construct the signal and plot the reconstruct signal for different values. For our assignment, we use n is equal to 5, 10, 20, and 30. And the last is present result, the Gibbs phenomenon.
Hi, Assalamualaikum. My name is Nur Hashmi Shah binti Rahimi Hazlim. I will be the second presenter and I will explain about the design calculation. First of all, for the design calculation, we need to find the C node, Cn, X node, and also Ft. And then for the graph that we get in the assignment, we will look at the appendix exponential first. And then for based on the appendix exponential, we can get the formula from there. And then for the C node will be equal to An, and then will be equal to 0. For the Cn, the formula is C node minus imaginary 2 X node over pi n. And then our X node is 3 because our amplitude is 3. And then we will substitute the X node into the formula to get the Cn. And then for the omega node, first, if we want to find the omega node, we need to have the period first. And then from the assignment, our group, we get the period is equal to 4. So we will substitute the period into omega node formula, which is 2 pi over t. And then we will substitute the t is equal to 4, and then we will get pi over 2. And then after that, we will proceed to find the Ft, which is Cn, sum of Cn exponent imaginary n1 over 2 pi t. And then we will find the positive and negative side of the Cn. Next. Okay. Next, the value of the phase for the negative and positive side, we will use formula square root of x squared plus y squared. And then for the positive, we will get the phase negative 90 degree. And then for the negative side, we will get the phase positive 90 degree. So lastly, for the design calculation, we will construct a table which have the value of n, and then the value of Cn, and the value of phase. So from the table, we will construct a graph. We will design the graph. First, the first graph is the magnitude graph, and then the second graph is the phase spectrum graph. And then we will just substitute all the information in the table into the graph. And then we will get the both graph same with the MATLAB after this. So that's all from me. I will pass to the next presenter.
Assalamualaikum. My name is Muhammad Syafiq Johari bin Muhammad Safawi. My ID number is EC21092. I will explain about discussion for question 1 using MATLAB. So this is our coding. And the first, we should define the parameters, and the value of p or t is 4, and we analyze the coefficients. For the n value is 5. Next, we should calculate the coefficients. The value of amplitude is 3. We'll multiply with exponential formula from 0 to 2, and for negative amplitude, negative 3, is we'll multiply with exponential formula from 2 to 5. And next, we construct the signal. After that, we plot the original and reconstruct signal. And the plot, the amplitude 3, we multiply with the 0 from 0 to 2, and the negative amplitude from 2 to 4. And the last is plot the amplitude spectrum. So this is our coding in MATLAB. We can see in this coding to define the parameters and the value of t. Also, we calculate the coefficient, the value of amplitude 3 and negative 3. After that, we plot the original and reconstruct signal, and also plot the amplitude spectrum. I would like to run our coding, and we got two graphs. And the first is the original signal. We can get the value of amplitude, which is 3 from 0 to 2 and negative 3 from 2 to 4. It's same with the manual calculation. And for phase spectrum, we got in 90 degrees. That's all from me. Thank you.
Assalamualaikum, my name is Muhammad Farhan Mazuki. My ID number is EC21091. So now I would like to explain the discussion for question 2, which is by using MATLAB. So this is our coding for question 2. So first of all, we define the parameters. So our t is 4. Then we analyze the coefficient. So our n value is 5, 20, 40, and 60. Then we plot the original signal. So original signal, our amplitude is 3 from 0 to 2 and negative 3 from 2 to 4, which is one cycle. Then we calculate the coefficients. Our amplitude is 3, multiply with the exponential formula from 0 to 2, and for negative 3, multiply with exponential formula from 2 to 4. So then it will reconstruct the signal, and this is the plot reconstruct signal. So this is our coding in MATLAB. So now I would like to run our coding. So this is our signal when we run our coding. So the original signal have 3 for the amplitude from 0 to 2 and negative 3 from 2 to 4. So first of all, we choose n is 5, 10, 20, and 30, and it show not too much the difference. So we change to 20, 40, and 60. So we run again the codings. So here, so we can see the reconstruct signal n equal to 5 until n equal to 60. It will show a lot of different signal from the original signal. So that's all from me. Thank you. Lastly, for the conclusion, the first one, we can conclude that manual calculation can prove our simulation result. That means by calculate our manual calculation, the final answer, we can get the sketch of phase spectrum and amplitude spectrum that same as our result simulations. So the next one is the value of n will affect the Gibbs phenomenon. That means by adding some value of n such as n equal to 20, 40, and 60, we can get the result of this construct signal that different from our original signal. And lastly, we may approximate a predict signal to any degree of precision by combining a sufficient number of complex exponential functions. So That's all from us. Thank you.